Hod Lipson, Driverless, Intelligent Cars and the Road Ahead, MIT Press. Welcome to the future of transportation. In the book Driverless, Intelligent Cars and the Road Ahead, Hod Lipson explores the imminent driverless revolution fueled by advancements in AI and robotics. The book highlights both the benefits and challenges that accompany autonomous vehicles, from life-saving potential and reduced pollution to job losses and privacy concerns. This summary provides a comprehensive overview of how vehicles will evolve from mere transportation machines into smart, autonomous robots, and the impact they'll leave on our society, environment, and lifestyle.
The Driverless Revolution. In the mid-21st century, driverless revolution will transform the transportation industry. Advances in deep learning AI and robotics will result in autonomous machines with superior driving awareness and perception. The benefits of increased safety, decongested cities, improved air quality, enhanced mobility, and free time will be contrasted with lost transportation jobs, privacy concerns, and ethical dilemmas. The adoption of driverless cars, which are expected to be twice as safe as human-driven cars, will save many lives and mitigate pollution. The challenge for driverless car engineers is not automating repetitive aspects of driving but engineering for the unexpected and rare cases. As sensing technologies improve, societies will adopt driverless cars gradually and safely. The pros and cons of driverless cars. Driverless cars promise convenience, increased usage, and reduced need for parking lots. However, they also bring potential negative impacts such as increased congestion, pollution, and vehicle degradation. Despite major tech giants and auto brands investing in car autonomy winking and laughing, the automotive industry lacks experience in robotic operating systems, seeking a gradual shift into driver assist and limited autonomy. The U.S. Department of Transportation favors a gradual approach, but this can lead to complacency and confusion. Nonetheless, federal transportation officials have the potential to throw their support behind driverless cars and save tens of thousands of lives. The journey of an artificially intelligent operating system in a driverless car. Driverless cars are the future of transportation, and the key to their success lies in the reliability of their artificially intelligent operating system, OS. These systems must be able to navigate and plan ahead in real time to avoid fatal accidents. Carnegie Mellon University's National Robotics Engineering Center is one of the many universities working towards solving the challenges that come with the development of such an OS. Researchers are even working to overcome Moravec's paradox, which makes it more challenging to teach perception and mobility to a machine than achieving difficult tasks like playing chess. Driverless cars rely on high-level controls for planning and navigation and low-level feedback for regulating systems like anti-lock brakes. While symbolic AI can handle search tasks, artificial perception requires machine learning to accumulate flexible patterns from vast data sets. Achieving 99.9999% accuracy, which is necessary in driverless cars, is a significant challenge. To ensure human safety, these OSs require redundancy and reliability, similar to avionics systems. The driverless car's middle-level autonomous controls generate a dynamic occupancy grid that assigns uncertainty cones to unpredictable objects like pedestrians, avoiding any unplanned downtime. A human-safe standard could be set by federal regulators wherein a driverless car that travels twice the distance of an average human driver would be advertised as having a human-safe rating of 2.0. In conclusion, driverless cars will revolutionize our mode of commuting, living, and shopping, but the success of this technology lies in the OS reliability and accuracy. The rise and fall of electronic highways. The 1956 Federal Highway Act allowed for the development of the interstate highway system, triggering America's car culture. General Motors and RCA teamed up to create an electronic highway that never took off due to high costs and the rise of consumer safety concerns. Now, with the development of autonomous vehicles, the US DOT is still thinking in outdated paradigms. Instead of costly vehicle-to-vehicle systems, autonomous technology only requires basic infrastructure like clear road markings and cheap IoT technology. Federal regulations could ensure safety, liability, and privacy for this new era of transportation. Several states have already implemented autonomous vehicle driver's license programs. The evolution of driverless technology. The trend of autonomous vehicles has gained momentum in recent years. However, many are unaware that its origins trace back to military technology, catalyzed by the robotics revolution spurred by the development of more powerful processors. It was in the 2005 DARPA challenge that Stanford University's autonomous vehicle, Stanley, demonstrated its newfound ability to learn driving patterns, thanks to pattern recognition techniques derived from game-playing programs such as Arthur Samuel's virtual copy of checkers. The evolution of vehicular AI relies heavily on the merging of different technologies such as big data, GPS, miniature components, and digital cameras, which work in conjunction to provide a 360-degree view of the car's surroundings. High-definition digital maps provide a layout of the road's topography, while differentially placed high frame-rate digital cameras capture light intensities to give the car a visual representation of the scene ahead in pixel arrays. Additionally, light detection and ranging, LiDAR, devices build a 3D model of the environment by painting the scene ahead with laser light. Radar technology tracks the speed and relative movement of objects by reflecting light-speed radio waves off conductive surfaces. Sonar sensors use ultrasonic sound waves for close-range sensing, while the GPS system triangulates the car's location. An inertial measurement unit provides an internal sense of balance by compensating for any GPS reception glitches. The collective senses of the car are controlled by its OS and sent and received by its CAN bus. The advent of driverless technology is forcing car companies to rethink their business models, and there are 4 distinct trends that are influencing this shift: electric cars, ubiquitous wireless, car sharing, and autonomous vehicles. The evolution of driverless cars. The growth of driverless cars is linked to the development of deep learning and fleet intelligence. The deep learning technology allows vehicles to collect vast amounts of data to generate internal maps that are continually shared with other cars in fleet learning. This process creates exponential performance improvement and facilitates the planning of journeys in detail. However, the data collection process could infringe on privacy, and there are ethical concerns about programming emergency situations. Future HD maps could have significant advertising potential and could alert tourists to local landmarks or show which streets have pull-off shoulders. A driverless taxi could also use facial recognition to market products or share traveler information with the authorities. Society must decide ethical codes surrounding driverless cars. The future of driverless cars. The driverless car industry aims to create vehicles that reduce harm, driving skills, and time spent driving while becoming smaller and more luxurious. However, automation can lead to income inequality, increased job loss, and new crimes such as hacking and robojacking. This driverless transformation is part of a robotic, Cambrian explosion, with exponential improvements in batteries, sensors, data storage, processing power, and algorithms enabling parallel functions in robotics and AI. As a result, self-improving algorithms may lead to AI self-awareness. Additionally, driverless cars may evolve to enjoy their work.
As we wrap up this fascinating journey into the world of driverless cars, it's evident that the transition to autonomous vehicles will be transformative for society as a whole. The benefits of enhanced safety, cleaner air, and increased free time will redefine the way we commute, work, and live. The technological leaps in AI, robotics, and sensing systems will no doubt make autonomous vehicles faster, smarter, and more efficient. However, it is equally crucial to address the concerns and possible issues related to job losses, privacy, and ethics to ensure a balanced and seamless shift into the driverless future. The driverless car revolution is set to be a game-changer in the world of transportation and beyond, bringing both unprecedented opportunities and uncharted challenges.